Hello everyone, welcome to this class. This class we are going to deal with addition, subtraction, multiplication and division of number bases. Now, the addition we do in base 10 or you're all used to, we are going to carry it out in other number bases. Now we have 66 plus 19. Let me not call it 66 because we are dealing with number bases, so you can't call it 66. 66 in base 12 plus 19 in base 12 plus 48 in base 12. You know, 66 is like the base 10 and pronunciation of it. So if we were to add, remember this is the first one and this is the tens, so you have 6 6. Now 9 t 9 8 and 4, so we are adding. 6 plus 9 is 15. 15 plus 8 is 23. Now remember this is in base 12, and what was the definition of base 12? We have 1 2 3 4 5 6 7 8 9, then t, and then e. You understand? It will only have one number less than the base. So if you count this 1 2 3 4 5 6 7 8 9 10 11, it cannot have the last. It will not be up to the base you're doing. It's like this is base 12, right? So let's do for base 10, which is the one we are already used to. That's 1 2 3 4 5 6 7 8 9. This is where it will stop. So it's equivalent. I'm using this base 10 too. Now when you are solving for a number in base 10 and you finish adding, the number is above that base 10, what do? You check how many times does it cross this base 12. 23, this is 23, right? 12 divided by 23, 23 divided by 12 will give you what? 1 remainder 11. Are we seeing it? So what we are carrying will be 1, and what we are putting down here is 11. It's like when you do, let me say you solve this in base 10, after you get 23, you know you are going to write 3 here and carry 2. Why are you doing that? For those of you that don't know why we do that in base 10, this is base 10 to be 23 over 10. You will now have 2 remainder 3. So what you really get after dividing in the base you are solving for is what you will carry and go to the next stage. Then the remainder is what you are putting down. So that's what we are doing equivalent of it in this base 12. So in base 12, 23 divided by 12 is 1 remainder 11. Now this 11 we are calling, all those things are base 10 pronunciation. You understand? Because that's what we already used to. We can't just start saying t remainder, 1 remainder t. I don't think we've gotten to that point. So 11 in base 12 is what? E. So we're going to write E. And we carry 1 and come here. 6 plus 1, 7. 7 plus t. We know that t means 10. Okay, let me add this thing here. You can see. So here is like 10 in base 10 and 11 in base 10. So 7. That one we carry and put here is 7. 7 plus t is what? That's like 7 plus 10 is 17. 17 plus 4, 21. So the next thing we are going to do is 21 over 12 is what? 1 remainder what? 9. So the 9 stays here. We'll now take 1 to the next place. 1 plus 9, 10. And 10 is t in base 12. So you have t. So your answer is t 9 E. As we solve more example, you understand what we are doing. So let's go to the next example. The next one is B, which is 5117 minus 324 in base what? 8. So let's just do something like this to separate this from our work. Sorry. So we have 5117 4. Make sure you maintain the unit, tens and all that. 2 3. We are subtracting. 7 minus 4 is what? 3. 1 minus 2, can it go? No. So you carry 1 from here. Here will now be 0. But when you carry 1, when you want to add it, what is that one going to be? When we do base 10, when we carry 1, that one is 10. That's why you see that when you carry 1 from base 10 and add it, will be 11. But this time around we are dealing with base 8. So when we carry 1, that one is no longer 10 because this is base 8. That one will be 8. So add that one here will now be 9. 9 minus 2 is what? 7. So 0 minus 3 cannot go. We carry 1 from here will be 4. That one will be what? 8. So this is 8. 8 minus 3 is what? 5. Then we add 4. This is your answer in base 8. So it's exactly what we do in base 10 that we're doing in other bases, just that instead of using 10, we are now using the base we are solving for. Let's go to the next example. The next example, we have 242 times 14, all in base 5. Base 5. So let's solve for it. Remember, always when you are solving, always remember your base 10 understanding of this. 4 times 2 is what? 8. Now, can you write 8 here? No, you can't write 8 because 8 is already more than base 5. You see, it's like when you are doing for base 10, you now say, let me say 4 times 8, you have 16. You know 16 is already more than base 10. That's why you see we write 6 and carry 1. You understand? Since 8 is more than base 5, what are you going to do? You are going to do 8 over 5, which will give you 1 remainder 3. So 1 is what you are carrying to the next part, while 3 is what you are dropping. Like, let's assume this base 10, we have 16. We are going to do 16 over 10, which is like 1 remainder 6. So we are dropping 6 and we are carrying 1. I know most of us might not know this is actually what we are doing when we are solving base 10. Maybe this base, trying to explain it with this other basis, is now opening our eyes to it. So that's what we actually do. So I will write down 3 here, carry 1. So 4 times 4 again, we have 16. Remember, we are carrying 1 already, plus that one we have, that's 17. So what we're going to do is 17 over 5, which will give us 3 remainder what? 2, because it's 15. 3 remainder 2. So we write 2 here, carry 3. So 4 times 2, 8. 8 plus 3, that's 11. So we come back again. 11 over 5, which is 2 remainder 1. So we'll now write the 2, carry 1 to the next place, and nothing is here. So that one will now drop here. Am I getting something wrong? Yes, I am. Actually, what I'm to drop is 1 and carry 2, but I'm going to go and reverse it. So this is 2 and this is 1. Sorry for that mistake. I felt it. So the remainder is what we are dropping, while the all you got is what you are carrying to the next stage. So remember our mathematics. 1 times 2 is 2. 2 is not above base 5, so we'll write it. 1 times 4 is 4, not above base 5. Above base 5. 1 times 2 again is 2. So let's start adding. This is exactly what we do in base 10. 3 will add itself and come down. 2 will add, give you 4. 4 will add. Now it's giving you base 5. So you divide again. 5 over 5. This one will give you 1 remainder 0. So you are dropping 0 and carrying 1. So I'll drop 0 here, carry 1. 5, 4, 2 plus 2, which is again 5. Sorry, 4 plus the 1 we are carrying, making it 5. We do the same thing. So we have remainder 0. So we drop 0, carry 1, and come here. So our answer is 1, 0, 0, 4, 3. This is for multiplication. Let's go to the division, which will be our last example before we go to the exercises. So the next one we are going to do is divide this in base 2 by this in base 2. So we are going to use our long division method that we use in base 10. Here we have 1, 0, 1, 0, 1, 0, and we have 1, 1, 1. Remember how we solve? You pick all of them as 1. Can it go for 1? No. Can it go for 0? No. Can it go for 1, 0, 1? No. If you look at it, you know that this 1, 1, 1 is bigger than 1, 0, 1. You understand? Because this one has 0 at the center, but this one is 1 throughout. So you don't need anybody to tell. So you now go for the fourth one. Can this go? Yes. Because this one has 4 places, where this one has 3 places. So if this divide this, what would it be? You know that this can go inside here once, but it cannot go twice. So if you multiply this by 2, you find out that it's already more than this again. If you multiply this by 2, notice that it's more than this, so it's 1. Another way you can know what you are doing is you check what is this in base 2, check what this is in base 10, until you reach where it will go, you divide, but you still be putting your answers in base 2, where you can say, let me, this is 7 in base 10, this is 5 in base 2. So when you divide, you know you have 1 remainder 2, so that 1 is what will be here. You understand? So 1 times 1 1 1, you have 1 1 1. You know how we do our long division, so you subtract this subtracted by this. Sorry, it's supposed to start here. I made a mistake. Remember, as I told you, it must relate to the unit. So I've already, let me call this 0 so I don't confuse my student. It's supposed to start here because I deal with this 4, so I went to the mistake. So this subtract, it won't go. You carry 1 here. What would you call the one you carry? Because we are doing base 2, it will be 2. So here will be 2. 1 plus 0 is 2. 2 minus 1 will now give you 1. Here is 0. 0 subtract 1, it can't go. You carry 1, put it here. Here will be 2. You carry 1 again, so here will now be 1 from inside these 2. You carry 1 again, call it another 2 again. Remember that here is 0 because we took 1 here, so here will now be 2. 2 subtract by 1, you have 1. Then, are we together? This place we are having, so here now we have 1. 1 minus, we have 0. But here is 0 since we took all those 1 over. 0 subtract is 0. So this is what we got. So we now drop the next one. Can this go? Yes, it can. If it cannot, we could have dropped the next one, because this is how we do it in base 10. So can this go? Yes. So 1 1 1 divided by 1 1 1 is still 1. So 1 times 1 1 1, we have 1 1 1. You understand? When you subtract it, all of them will give you 0 0 0. So you drop the last 0. 1 1 divided by 0 0, your answer is 0. 0 times 0 0 0. So your answer is 0. This is your answer. 1 1 0 in base 2. I don't need anybody to tell me that this is confusing. But before we go to the next example, I want to show us something in base 10, so we have a little understanding of what we did here. Let's say we are dividing 2 by 1 1 2 2. First, what we are going to do is, can 2 divide 1? No. That's what we did. We would pick it and check till we reach here before we start solving. Can 2 divide 11? Yes. 11 divided by 2, we have 5. 5 times 2, we have 10. Then we now subtract, we have 1. So the next thing, we start dropping. 12 divided by 2, we have 6. 6 times 2, 12. 0. We drop the last 2. 2 divide 1. 1 times 2, 2. 0. So we're having 5 6 1. So that's exactly what we did here. It's almost whatever we are doing in base 10 is what we are doing in other bases. Just that because the other bases are not something we are used to, it will be a little bit confusing. When I did 1 1 divided by 10, I know it's smaller. Even when it is 1 2 3, I know it's still small. I have to go for this, and I got 1. 1 times, I get 1 1 1, and I subtract. After subtracting, I got 11, and I'll now drop the next one, because this cannot divide, and I'll drop the next one. I have this divide 1 times this, I drop the last 0 till I got this. But if this is confusing to you, best thing is convert to base 10, solve in base 10, bring it back to your number base. Exercise 3I 1A, we have this in base 2, we have to add it, so we have 1 0 1 1 1 1 0 1. So it repeated itself. 1 plus 1 2. So you now do 2 divided by 2, that's 1 remainder 0. You put the 0 here and carry the 1. 1 plus 1 2, plus this 1 3. 3 divided by 2, you have 3 divided by 2 is 1 remainder 1. So we have exercised this one. We'll carry 1. So the remainder is what we are putting here. We'll carry the 1. So the 1, 0 plus 0 is 0, plus that one we are carrying, say 1. 2 plus 2, 1 plus 1 2. 2 divided by 2, 1 remainder 0. So write 0, carry 1. So nothing here. We drop the 1 here. This is our answer. This is in base 12. So we have T0 E and E, E, T. So E, this is like 11. 11 plus 11 is what? 22. 22 divided by 12 is 10, right? That's 1 remainder 10. 1 remainder 10. So the 10 is T. So we'll write the T. Carry 1. 0 plus 11 is 11 plus the one we are carrying, 12. 12 divided by 12 is 1 remainder 0. So we'll write the 0. Carry 1 again. T plus T, which is 10 plus 10, 20 plus the one we have here, which is 21. So 21 divided by 12 is 1 remainder 9. So we'll now write 9 and carry the 1 and put here. So our answer is 190T. So we'll go to number 2, which is like subtraction. This is in base what? 5. 3, 2, 1 minus 1, 1, 3, or in base 5. These ones are addition. So 1 minus, it cannot go. We'll carry 1 here. So what will be left here will be 1. Put here. Because we are doing base 5, when we carry 1 is 5 that we are carrying. 1 plus 5 here now is 6. 6 subtracted by 3 is 3. 1 subtracted by 1 is 0. 3 minus 1 is 2. So this is your answer in base 5. This one is base 12 and this one is base 2. Let's come here. 405 minus 217, or in base 8. Can 5 subtract? No. So we'll carry 1 from here. Here will now be 3. Add that 1 here, 8. Carry 1 again. Here will now be 7. 8 plus 5 is what? 13. 13 minus 7 is what? 5. Am I getting? No, 6. So 7 minus 1 is what? 6. 3 minus 2 is what? 1 in base 8. So this is your answer. See how simple it is. Exactly the same way you solve it in base 10, just that when you want to carry a number, let the number you carry be the base you are solving for, and the same thing applies for division. When you want to divide it by the base you are solving for, then the remainder goes down. The whole number is what you are taking to the next side. Let's go to the next example. So let's solve for 3, 5, 6 in base 8 divided by 7 in base 8. So we have 3, 5, 6 divided by 7. I think I missed something. Should be something like 3, 5, 6. Can we go? So are we together? Let's start. So solving this in base 8 will take us to a deep forest. So the best thing is to convert to base 10 and solve and bring it back to base 8. The reason why the one I did here, I have to solve it in base 2 despite the difficulties, because that was how it was done in the textbook. But when you don't have a specific way you are being told to solve it, just go convert to base 10, solve and bring back to base. It's very easy. So converting this 3, 5, 6 to base 10 will simply be 3 times 8 plus 5 times 8 plus 6 times 8, 0, 1, 2, which will give you 3 times 8. 8 times 8 is what? 64. 64 times 3. 64 times 3 will give you 192 plus 5 times 8 is what? 40 plus 6 times 1, because 8 raised plus 0 will be 1, will now be what? 6. So by the time you add these 3 figures, you'll get 238. Now 7 in base 8 converted to base 10 will still give you what? 7, because it will just be 7 times 8 raised power 0, which is still 7. So we are now dividing this by 7. We have 238 divided by 7. Now we are solving in base 10, because this is in base 10 and this is also in base 10. Are we together? So 7 go here will be 3, carry to 7 go here will be 4. We're having 34 in base 10. So this 34 in base 10, we simply change it back to base 8 to get our answer. So 34 because we're changing to base 8, we divide by 8. 8 divided by 34, we get 4 remainder 2. 8 divided by 4, we get 0 remainder 4. So we take it up, it will be 42 in base 8. So this is our answer. So when you have division, multiplication, addition, you can division and subtraction are multiplication and addition and subtraction are easier to solve in the base if you understand it, but division and multiplication are a little, especially division. So when you are dealing with division, it's more advisable to just convert to base 10, solve and bring it back. Let's solve for this. 48 multiplied by 15, or in base what? 12. 5 times 8 is what? 40. Correct? So you now do 40 over 12 because you're dealing with base 12. You are having 3 remainder 6. So just put the 6 here. We are carrying 3. 5 times 4 is what? 20. 20 plus 3, 23. So you do 23 over 12. We have 1 remainder what? 11. And that 11 is called E. So plus the one we carry, it will be 1E6. So when 1 times 48, you are still having your 48. So 6 drop here. 11 plus 8, 19. So 19 over 12. You have 1 remainder 7. So I'm writing my 7 and I'm carrying 1. 1 plus 4, 5, plus the one we carry, 6. So this is your answer. 6, 7, 6 in base what? 12. So it's much easier to do addition, subtraction, and multiplication in the number base, but division is always more hard. So I advise my students for division, convert to base 10 and bring it back. So now we are dealing with 1. This one we need a longer place to solve it. So we are dealing with 1 0 1 1 0 1 0 1 1, and we have 0 1 1. So when 0 multiply, everything will be 0. So I don't need to stress myself. 1 2 3 4 5 6 1 2 3 4 5 6. So 1 1 multiply 1, we have everything repeating itself. 1 1, that's 1 here, 1 1 here, 1. You know, in multiplication you'll be shifting it one side as you're multiplying, so don't forget. So 1 multiplied by 0 is 0. 1 multiplied by 1 1. 1 multiplied by 0 again, 0. 1 multiplied by 1 1 again. So the same thing with this one. 1 multiplied by 1 1. 1 multiplied by 1 1. 1 multiplied by 0 0. Multiplied by 1 1. Multiplied by 0 0. Multiplied by 1 1. So you have something like this. 0 1. 1 plus 1 is 2. So you can't write 2 because you are dealing with base 2. So 2 divided by 2, which is 1 remainder 0. So you are writing 0, carrying 1. 1 plus 1 again, because 0 plus 1 is 1, plus the one we are carrying, that's 2 again. You are write 0, carry 1. 2 again, write 0, carry 1. Come in here. 1 plus 1, 0 again. What am I saying? All these things are 2, 2, 2, 2, 2, not 0. So let me start from here. Here I have 1. 1 plus 1 is 2. 2 divided by 2 is 1 remainder 0. So the 0 is here. I take 1. Add that one to this one. I have 2 again, which is 1 remainder 0. I write 0, carry 1 to the next one. Add here, which is 2 again. 1 remainder 0. I write 0, carry 1, come here, which is 2 again. 1 remainder 0. I carry 1, come here, which is 2 again. 1 remainder 0. I write 0, carry 1, come here, which is 2 again. 1 remainder 0. Write 0, carry the 1. And that is where I stop. So the answer is 1 1 2 3 4 5 6. 0 into 6. Then 1 at the end. So that's for multiplication in base 2. This is your answer. It's just very simple. So for this is another one that has to do with division. As I said earlier, we can go for the division but is to take us to a deep forest. So best thing, convert to base 10. Convert this to base 10, convert it to base 10, solve it and bring it back to base 2. So in this case, I will jump step. I will not show the conversion. I will just tell you what this is in base 10. So if I convert this to base 10, I'll have 45 divided by, if I convert this to base 10, I'll have 5. So 45 divided by 5 is what? 9. So convert this back to base 2. 9, 2. 2 divide, we have 4 remainder 1. 2 divide, we have 2 remainder 0. 2 divide, we have 1 remainder 0. And 2 divide, you have 0 remainder 1. So you take it up. And your answer will be 1, 0, 0, 1, or in base what? 2. Very, very simple. Rather than going through the long division we did in the last class. So the last example we are going to do, we are going to solve for. This is number 5. We are given this, and it is in base 5. And we are being told to look for this missing number. This was added to this, added to a number, added to this, and we got this, and we are looking for the missing number. It's missing. Just add these 3 and subtract it from this, and you get the missing number. Since all of them added together to get this, when you add this, subtract it when you add this 1, 2, 3, subtract from this, you get that. So let's start. Let me start with 2004. Remember, it's in base 5. 3, 4, 1, 1, 0, 2. So we add 4 plus 3, 7 plus 1, 8. So 8 divided by 5 is 1 remainder 3. So I'll write the 3 here, carry 1, put the 1 here, which is 5. 5 divided by 5 is 1 remainder 0. I'll write the 0 here, carry 1, put here 1 plus 1, 4 plus 2 plus 2, 4. That's 1 plus 2 is 3, plus 1 we are carrying, that is 4. 4 is now above 5, so we'll put it. This is now above 5, we'll put it. So now we subtract this from this. So it will be 4, 2, 4, 0 minus 2, 4, 0, 3. So carry 1 from here. Here will now be 3. Here will be 5 because we are dealing in base 5. So it will be 5. 5 minus 3 is 2. Since here is 3 minus 0, 3 come down. Here can now go. Carry 1 plus from here. Call it 5. 5 plus 2 is now 7. 7 minus 4 is 3. Here is remaining 3. 3 minus 2 is 1. So this is the number we are looking for in base 5. And this is all for this class. If you have any question, do it to drop it in the comment section.